Alright, this is the video for section 1.1, angles and radian measure. Not only is this the first section of Unit 1, but it's the very first section of 3 whole units that are on trigonometry. So just to kind of repeat something that you may or may not have been in class to hear, the first 3 units of our course of Precalculus are all focused on trigonometry. So this is the very, very start of it, okay? And we're definitely going to be laying a little bit of important groundwork, especially for Unit 1. So we're going to get to what radian measure means shortly, but first a couple things about angles. The first thing is that we're going to be thinking of angles now. We're going to be thinking of them as placed in the xy plane like so. So this thing called standard position, where we draw it, with the initial side or the starting side placed on the positive x-axis like this, and the vertex at the origin. And this is what we would call the terminal side. So the initial side is where it starts, and it'll always start here. And the terminal side will be wherever it terminates or ends. And this symbol is the Greek letter theta, and it's just simply a variable we're going to use a lot when it comes to the measure of an angle, how many degrees some angle is. So theta, like theta degrees. It's just whatever number of degrees. So again, that's called theta. And let's see here. So if we want to think of this spot or location as, I guess, how many degrees would this be if we went from like just here to here? Anyway, 0 degrees. So that would be like the 0 degree mark. And if an angle opened up from this spot, which again we're calling like the 0 degree mark, if we opened up an angle from here to there, the y-axis right here, how many degrees is that? Do you know? Do you know? It's 90 degrees. And if an angle opened up from here all the way to there, that would be 180 degrees. And we could even keep this going, starting from here, going all the way to here. How many degrees would that be? All of this would be 270. And to kind of plant an idea in your head and kind of for future reference, I guess, we could even think of going all the way around, and how many degrees would that be? 360 degrees, getting back to 0, so to speak. The other thing that we need to introduce about angles, and especially when it comes to drawing angles on the xy plane like this, is that we can have positive angles, and we could also have negative angles, as weird as that might sound right now. Anyway, these 2 angles right here and right here, those are positive, and these 2 angles right here and right here are called negative. And as always, if even if I moved on from like the last page too soon, if I ever click through this too fast, you can always. That's one of the good things about doing these videos and having it as a video. Pause the video and write all this down, and give yourself a chance to write this down, and so you can absorb all the information a little bit better, But anyway, giving you a chance right now to write this stuff down, or again, like I said, pause the video if you need to. But anyway, think to yourself, once you have this written down, what do you think is the difference between a positive angle and a negative angle? What do you think makes a positive angle positive? What's the defining characteristic? Think about that. And the answer is this goes in this direction, like up and around, which you could basically call counterclockwise. And a negative angle is where it goes in the other direction. It goes down and around, essentially in a clockwise direction. And before we move on to the next page, let's estimate, like I said, an approximate measure of all these angles. Okay. Let me get my pen here. All right. So how many degrees do you think this is? Like, how big is that positive angle? Maybe you're thinking about 45 degrees, looks to be about halfway between 0 and 90, or halfway to 90. If you disagree a little bit, think it's a little bit more, think it's a little bit less, that's fine. Just kind of doing a basic approximation. How about this angle? How many degrees do we cover from here to here in the positive direction? Well, it looks like we opened up even more than 180. Not as much as 270, obviously, but, hey, feel free to take a moment, pause the video, and think about how many degrees you would say that is. You don't need to bust out a protractor or anything, but I'm just going to go ahead and quickly say, how about 225? If you disagree slightly, that's fine. Moving on to the negative angles. Now remember, this is in the negative direction. So going from here in this direction to here, that would be negative 90. So negative 90, negative 180, and even more than that, So I'm going to go ahead and say, like, we're not going all the way to negative 270. So let's just go ahead and say negative 225. Feel free to write something a little bit different. I don't care. And this guy over here looks like I would say, eyeballing that up, we're certainly going more than negative 45. We're definitely not going all the way to negative 90. I don't know, just to kind of say something, let's just say negative 65 degrees. If you disagree, whatever. Moving on. Okay. Now we're getting into what a radian is. Okay, now, to give you, again, some pretty good perspective, if you were to think about measuring, I don't know, the length of your dining room table, like how long is your dining room table or whatever, or the length of a piece of rope or something. My point is, you could measure that table in inches, you could measure it in feet, in centimeters, in yards, in meters. There's all kinds of different units you could use to describe the length of something. Well, radians happens to be just another unit we can use to measure the size of an angle. All right, so all your life, or not all your life, but for long enough in math class, in your math life, I think you've been comfortable with degrees. Like you can visualize what a 90-degree angle looks like, or a 45-degree angle. There's 360 degrees all the way around a circle, right? So I think you should be at least fairly comfortable with degrees. So radians are brand new, but it's just simply another kind of unit that we can measure the size of angles with, So just like we have feet and inches, or meters and yards, we have degrees and radians. So the radian measure of any essential angle is the length of the intercepted arc divided by the circle's radius. So we're going to call S the arc length right here. Arc length, like the length of that arc. And that's theta, of course, as the angle. And the R would be the radius of the circle. Okay? So we're going to, again, like basically what it's saying is, if you were to put some angle in the middle of a circle, or if you drew a circle around your angle, you could basically get your measure of radians by doing some random radius of whatever circle you drew, and the arc length, and pretty much do this. So this is kind of like a magic formula that can give you radian measure. Okay? S divided by R. So over here really quick, 1 radian, for you to have an angle of 1 radian, with it being S divided by R, your arc length would actually have to equal what? The radius. Okay? Now, putting that into a pretty, cheap example, or very, very simple example, here we go. What is the radian measure of a central angle in a circle with radius 6 inches that intercepts an arc of length 15 inches? Well, what we have here is them just kind of blatantly giving you the ingredients of your formula. Like they gave you S, they gave you R, so all you got to do is plug it into the formula. Again, not a very deep problem, just plug the numbers into the formula that they gave you for free. And 15 over 6, can we do anything with 15 over 6? 15 inches over 6 inches, that reduces, and you should always reduce or simplify fractions if you can. So final answer is 5/2 radians, of course. And something I might repeat in a few minutes, if you want to write that out, I mean, it is radians, but you don't have to really write that out all the time, especially with radians. Because what I might not have to say later now is, if the measure was in degrees, you would see the degree symbol. Like, notice how I denoted this as degrees with this little degree symbol that we use all the time. So anyway, it's 5/2 radians, or 2.5, 2.5 radians would be fine. It's equivalent. All right, so something to challenge your brain a little bit right now. How many radians are in 360 degrees? Okay, this is kind of like asking, how many inches in 3 feet or something. Just how many radians would be equivalent to the entire 360 degrees? Well, all you really know to go off of here is, we know that the angle of radians will be equal to an arc length divided by the radius, for this particular angle, okay? Well, for 360 degrees, what would be the arc length? It would actually be the entire circumference. So 2 pi r right here, and then really quick, what happens from this? Like if you look at 2 pi r over r, is there anything you can do with that? And the answer is, the r's will cancel out here. They'll divide out to 1. So 2 pi would be, I guess, sort of like a final answer. And don't forget, people, that 2 pi is just a number because pi is a number. What number is pi? Well, it's approximately 3.14. So 2 pi radians is an answer because it's just a number. So 360 degrees is equal to 2 pi radians, which, what is 2 times pi? About 6.28. You can check that out on your calculator for yourself, but, so I guess all the way around would be just over 6 radians, to give you a little bit of an idea. Anyway, let's cut to the chase a little bit. Like, this is a major big time point, okay? It's one of the big ideas of this first section. So think about it for a second. If 360 degrees is equivalent to 2 pi radians, how many radians would be 180 degrees? Think about it. How many radians? maybe you figured it out that it's pi. All right. Now, this is something that you really, 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 really need to commit to memory. Okay? That's a big idea. That is the best way for us to remember how radians and degrees are related to each other. That there are 180 degrees in pi radians, or that they're equal to each other. So, the next thing we're going to do is a few examples on converting between the two. So there's going to come times here and there that we need to convert from degrees to radians or radians to degrees. And so here we go, convert each angle in degrees to radians. So here's what we do. We take the fact that we know that 180 degrees is equal to pi radians, and we use that, and what we're going to do is multiply by that conversion rate or ratio as a fraction, right? So again, the bottom line here, just to kind of repeat myself a little bit and emphasize something. To convert from degrees to radians, we multiply by pi radians over 180 degrees. And it's vital that we put 180 degrees on the bottom and pi radians on the top, so that the degree units will actually literally cancel out. And the degrees will go away, and what unit will be left over? Radians. So degrees go away, and we end up with something that's in radians. And then from there, now we just have to multiply this together. And if you want to think of it as a fraction times a fraction, that's fine. That's what it is in a way. So how do we multiply two fractions together? We multiply across. We do numerator times numerator and denominator times denominator. Is that a good final answer? No, because it can reduce. So 30 over 180 reduces to 1 over 6. So 1 pi over 6, or just pi over 6 would be my final answer. Like, I could approximate that. I could get my calculator out and do 3.14, or just pi. There's a pi button. You could do pi divided by 6, and you could approximate that, okay? But pi over 6 is the better answer. It's exact, and it's just way more common way you're going to see these measures in radians, okay? And I'll even say this now. Why not? Radian measures will almost always have pi in it somewhere, okay? Once again, radian measures almost always, they don't have to, but pretty much always it'll be pi over 6, 3 pi over 4, 5 pi over 8, pi over 2, whatever, okay? So, next example, how are we going to take 90 degrees and convert it to radians? Well, we're going to multiply by pi over 180, of course. And the degrees are going to cancel out. And when we multiply 90 times pi over 180, once again, if you want to think of it like that, we're going to get that. Is that the bestest final answer? No, because that reduces to 1 pi over 2. 90 and 180 will sort of like cancel with each other and simplify to 1 pi over 2, or just pi over 2. Okay? And if you want to, maybe you should try, if you're doing this for the first time, like if you missed class and you're doing this on your own as a makeup, okay? Maybe you should, at this point, try negative 135 on your own, okay? Pause the video, try it on your own. But what's going to happen here is we're going to end up with negative 135, idiot. And what does negative 135 over 180 reduce to? I think negative 3/4. I think negative 3 over 4. Pretty sure. I'd hate to be wrong at a time like this, so 135, I'm checking a calculator. Yep. So negative 3 pi over 4. And again, sorry for repeating myself here, but you could approximate that, but we're pretty much almost never going to do that. We're going to leave it as negative 3 pi over 4. So that would be a measure in radians. And once again, I don't have to write the word radians. It's understood that it's in radians because you don't see what symbol. You don't see the degree symbol, okay? So these measures of these angles are just assumed to be in radians. You don't have to write the word out. Now we're going the other way, okay? And what's here in green is exactly what I've already said twice. If there's no degree symbol on an angle measure, it's in radians, or you can assume it's in radians. And again, I'm going to keep going here, quickly or efficiently, just kind of going through. If you need to pause the video or go back a page, if I'm not giving you enough time to write everything down, feel free to pause and go back and re-watch certain parts. But if we're going from now pi over 3 radians to degrees, now we're going to multiply by the same fraction but flipped, because now we want the radian units to be on the bottom, because now we want the radians to go away and degrees to be left over. So radians go away, and what we're left with would be in degrees now. So the radian units cancel, but something else cancels. Pause the video, or I'll give you at least a few seconds here. What else cancels? The pi's cancel. So, now when we look to multiply, and I mean technically there's a 1, right? 1, 1, whatever. And when we multiply that together, we get 180 degrees over 3, which that definitely simplifies to be 60 degrees. So pi over 3 is 60 degrees, okay? And I'll give you a little secret shortcut now. Instead of even doing this multiplying by this conversion rate, okay, if there's a pi involved, right, what is pi radians equal to? How many degrees are the same as pi radians? Well, 180, of course. Okay? So if that's true, here's what you could have done instead, and it's what I do and what I'm probably going to recommend you do, as we go forward here, like, right? Just, as we do sample tests and quizzes and blah, 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 just plug in 180 for pi. If there's a pi here, just plug in 180 for pi because they're equivalent. Okay? Think about if we would have just done that in the first place. 180 degrees over 3, 60 degrees. How about here? You could totally feel free to just plug in 180 for pi. And you'd have like negative 5 times 180 over 3. But I think, and hey, if you want to do that way, fine. But if we multiply by the ratio, the radian and the pi's will cancel, and we'll be left with negative 5 times 180 over 3, which, hey, makes total sense, right? And grabbing my calculator, negative 5 times 180 divided by 3 simplifies or gets us negative 300 degrees. Okay? Okay? Final example's kind of weird. Just, Just getting that out there, you know, all cards on the table. Kind of a weird example, mainly because there's no what in it. There's no pi. Like I said, almost every time you see a radian measure, it's going to have pi in it somewhere. But it doesn't have to. You know, case in point, 1 radian, right? So let's multiply by 180 over pi. And I mean, the radian units, this is pi radians, 1 radian. The radian units will still cancel, but this pi won't cancel with anything. So what we basically get is 180 over pi. Okay? And that's it, and that's in degrees, okay? Now you could leave it like that, or if you wanted to, and I will now, just, you know, just for fun, 180 divided by pi, that is approximately, I'm going to have to approximate this obviously, 57.296. Okay, so 1 radian is approximately equal to 57.296 degrees. Oh, speaking of that, to give you a little bit of, again, perspective here, when we think of the relationship between radians and degrees, you should think of the whole 180 degrees is exactly pi radians. But here's a couple other interesting conversion rates. We don't really use them, but, you know, just to kind of make you aware, you know, whatever. We just pretty much saw this, that 1 radian is about 57.3 degrees. Well, 1 degree is approximately 0.02 radians, 2/100ths of a radian. Crazy. But again, you know, not to repeat myself too much, sorry, but 180 degrees being the same as pi radians, that's our big conversion ratio, okay? Drawing angles. Moving on to just drawing them in standard position if they are given in radians. Well, I bet you could come up with this strategy on your own. If I give you an angle like negative pi over 4 and I want you to draw that on the xy plane, what are you going to do? First, what? Convert to degrees. So how about we officially start using the shortcut now? And remember, what I mean by that is just replace pi with 180 and it'll be in degrees, just like that. So bam, bam, and it turns out that negative pi over 4 is negative 45 degrees. As always, feel free to pause the video and give yourself time to write all this down or whatever. But where is negative 45 degrees? Right there, okay? And how about we start, as a rule, adding that little arrow, the directional arrow. Because remember, this is a negative angle which goes clockwise, like that. And maybe you're wondering, you know, where was this guy? The initial side? Don't really have to draw that, you know, at least I'm not going to. It's not life or death, at least for me, if you don't draw the initial side of your angle. Anyway, moving on, 3 pi over 4. Well, we're just going to plug in 180 for pi and do 3 times 180 divided by 4 and get 135. Okay, where is 135 degrees? Remember, if this is 0 and that's 90 and that's 180, where's 135? Right there. And again, let's always make it a point to include that. That's a positive angle. Okay? Try the last one on your own. I dare you. Which means pause it. And then unpause. 13 pi over 4. Well, in degrees, that would be 500. What? 500. Where is 585 degrees? That would mean we got to go all the way around is 360. Well, just keep going. Okay? How far do we got to keep going? Well, I'm going to do some quick math on my calculator. 585 minus 360, that's 225. So, if we go all the way around is 360, we got to go another 225 degrees, which would be like that. Look at that. So, oops. 585. That's that guy. Let's just leave it at that for now. Ooh, this should probably be on your notes paper. Just, if you look at the figure, what are these negatives? Okay. Looks like this gives you a lot of the conversions, right? Like, so this is kind of handy. See how 90 degrees is the same as pi over 2 radians. 150 degrees is the same as 5 pi over 6, which is kind of the same as 5/6 of pi, right? Just like 120 degrees is 2/3 of pi. Remember, what's pi? 180 degrees. 300 degrees is 5/3 of pi, or 5 pi over 3. And, there's a lot here. So, nice little reference guide. Moving on, I think this is the final topic of section 1, and it's coterminal angles. So, a little definition for you. A little vocabulary, if you will. So, coterminal angles are angles with the same what and what sides? Initial and terminal sides, but different rotations. Give you a few seconds to write that down, but pause if needed as always. So these angles, 210, which goes from here to here, 570, which went all the way around once and kept going, another 210 degrees to end up at like the same location, or like I said, the same terminal side, but it had a different number of rotations. This happened on the first rotation. This happened on like the second rotation. And this one was a negative rotation, negative 150, but it ended up in the same terminal spot, okay? All these angles are coterminal with each other. So you can't really say, I don't know, this is something that you'll just kind of like know naturally or whatever. Like it should go without saying that the nature of something coterminal is, you can't say that one angle is coterminal. You have to say these two angles are coterminal with each other, or these three or these four angles are coterminal with each other. Okay? So 210 is coterminal with 570, which is also coterminal with negative 150. All right. Example time. But first this. What does this say? The key to finding a coterminal angle that is positive and less than 360, also 2 pi, 360, 2 pi. What is that? Well, since coterminal angles differ by 360 degrees, or a multiple of 360 degrees, just add or subtract 360 until you get between 0 and 360. So I think these examples will make it really clear what we're doing here and what all that means. So example A here. The directions, of course, say find a positive angle less than 360 or less than 2 pi radians that is coterminal with 495 degrees. So in my mind, in my crazy mind, the directions are basically saying, there's a lot of angles coterminal with 490, but what is the simplest positive one? Like, what's the bestest coterminal angle for 495? That's, in the positive direction on the first rotation. Well, how do we figure that out? Well, like it says up here in blue, just subtract 360. And 135 fits the description of where we want to end up, So 135, which is on the first rotation, and it's positive, and it's the bestest coterminal angle for 495. Well, this next example, for negative 240, we're going to have to add 360, and we get 120. And so that's that answer. But then we get 17 pi over 3. Well, what are we going to do first? Okay, well, I don't know. It occurs to me to point something out. We could leave this in radians. What would we do to find what's coterminal to 17 pi over 3? We're not going to subtract 360. We're going to subtract 2 pi. If we're leaving everything in radians, we could just subtract 2 pi, right? So we could, but we're not. So just like, we usually are going to be doing here from here on out, if we see something in radians, let's just quickly change it to degrees. And again, just to, to be repetitive, how do we know that's 1020? We plug in 180 degrees for pi, so it'd be 17 times 180 divided by 3, and that's 1020. Well, if we subtract 360 from 1020, what the heck does it even get? Let's see here. That's just going to get you to 660. 660 is still too big. So we subtract 360 again because we need to get a final answer like that, And I think that's all there is to that section.